So this is going to be a video on polar equations, specifically if we're looking at conics. So that means that when we take the polar equation and we convert it into rectangular form, the recognizable rectangular form will be a specific conic. So, for the first example, we're going to use r equals 1 over 3 minus 3 cos theta. And it might be helpful, I don't know if you guys have memorized these already or not, but it might be helpful to write that r is the same as the square root of x squared plus y squared, and that x is the same thing as r cos theta, and y is the same thing as r sine theta. Okay, so what's the first thing you would do if you didn't want that to be a fraction anymore? Yeah, I'd multiply it on each side. So on the right side I'm going to have 1. What do I end up having on the left? Yeah, so at this point, this is where different teachers teach it different ways, and it comes down to kind of what you're comfortable with, I guess. So at this point, this is where I like to do the substitutions, and I always do the problems the same way. If you find that you would like to do it differently, you're welcome to kind of play around with the problems and do the substitutions differently. It's kind of like Jake's favorite, where we did analytic trig, and there were all sorts of different substitutions you could do, and they all kind of arrived at the same answer.
But we
right?
don't have to. Right?
But you don't have to. No, you can always do it this way. So this is the way, I played around with it a little bit, and this is the way that I liked the best. So this is what I'm going to show you. So I replaced the r with x squared plus y squared, the square root of it, right, because it's plain old r, not r squared. And then I replaced the r cos theta with x. And what I saw next was for me to get that radical out of the problem, at some point I was going to have to square it, right? To get rid of a radical, that's how you get rid of it. So what I wanted to do was kind of isolate that radical. So the first thing I did was add the 3x to the other side. And this process is going to feel kind of weird right now, but it really does work out the same every time. So once we do it once here, then you'll be able to just kind of follow this process. So for me to get the radical alone, I went ahead and divided by 3. Okay. So all we've done so far is we did some substitutions, and then we got the radical alone because we want to be able to get the radical out of the problem. So at this point, I'm ready to square both sides to get rid of that square root. So on the left side, that just leaves me with x squared plus y squared. And you have to be careful on the right side. What do you guys think I should do with the right side? Foil, yeah, I'm going to write it twice, just to remind myself to foil it. So what would the top be? 9x squared, right? And then 6x plus 1 times 1 is 1. Okay. And on the bottom we've got 3 times 3, which is 9. Okay. How could we make that right side not a fraction anymore? Yeah, multiply by 9. So we've got 9x squared plus 9y squared equals 9x squared plus 6x plus 1. Alright. Can somebody tell me what conic that is?
Circle. Wait.
I've heard circle and I've heard parabola.
Oh, no, they can't.
So let's continue on in the problem. Let's get it into general conic form. So what should we do to get it in general conic form? Put everything to one side. Where do you want to move everything? To the left? So we'll do minus 9x squared, and we'll minus the 6x, and we'll minus the 1. So that whole side equals 0 now. What happened with the x squared? They canceled out. So we just have 9y squared. We still have the negative 6x, so we still have the negative 1. So what was it? It was a parabola. It was a parabola, yeah. Now, you're going to have to pay close attention to your instructions. If I tell you that I want it in standard conic form, then that means I want the conic form where you can see what the vertex is or see what the center is and all that stuff. If I tell you I want it in the general conic form, then I want it to look like this, okay? Some of the answers today are not nice, so I'm going to tell you I want them all in general conic form, okay? So all of them, you can just make it equal 0 and then you're good, all right? Okay, let's try another one. You guys are going to get bored of these real fast because they really are all the same. So let's look at you know what's funny is I'd done that one wrong on my notes, so I thought it was an ellipse, but it's not. Alright, so we're going to do 4 over 3 plus 2 sine theta. When I FOILed it on my notes, I got 3x times 3x was 3x squared. No? It's not funny? I thought you guys would enjoy that. Okay, how do I start this problem? I'm going to do that on each side. So it is a long process, but you're going to feel, this process will probably feel like deja vu this time, because we'll be like, we literally just did all those steps. Deja vu is when you feel like you've, it's more than just memory, it's like you feel like you've been there before, like you feel like you've had that exact same moment before, yeah. Alright, what can we do with the R's? What do we do? Alright. What do we do with the R sine theta? Make it a Y. Okay. So at this point, what are we doing? What's the goal? Yeah, get the radical by itself so that we can get rid of it. So I'm going to go ahead and minus the 2y over. You guys okay over there?
I'm always weird this happens. Remember when you kicked the desk really hard?
In one of my classes, there's a girl that sits right behind me that like farts a lot.
Are you kidding? No, you're joking.
No, I'm not joking. And like people at her table think it's funny, and they like, so they'll laugh about it, but they don't like judge her. They're all like friends, and it's a goofy thing. But then like everyone else hears it, and then she gets embarrassed because that happens. Or like she farts and the whole class is like, rah, rah, rah. And then she's like, oh my gosh, they all know I farted. And I'm like, well, if that's the case, then like excuse yourself and fart in the hallway where you're farting.
I don't really support like the farting in class.
Yeah, like, me either.
Ideology.
No. Yeah, you know.
Like, I do a lot of it.
So you guys can enjoy that later if you need to watch the video. All right. Wait. What's the next step? Divide by 3. Okay.
Wait, who's the farter? You guys.
I can't tell you who the farter is.
What period?
It's a secret. Alright. Then what should we do at this point? Yeah, square each part, which on the right side will include foiling. Yep. So, since I'm squaring the right side, I'm going to go ahead and write it twice. You know, the reason I did it wrong on my notes is because I didn't write it twice. I just foiled it in my head, which is always dangerous. So, what do you guys get when you foil those? 4y squared minus 16y over 9. Okay, do you guys see how similar these problems have been? They're essentially the same thing. Okay, what should we do next? Multiply by the 9. Anyone have a prediction about what it's going to be?
It looks kind of, that's an ellipse, ain't it? That's an ellipse, ain't it? That's the worst I've ever said in my entire life.
But it's been in his heart for so long.
Never say that.
All right. If anyone wants to go back and enjoy that later, that happened at about 11 minutes and 30 seconds on the video. Okay. Let's go ahead and write this in general conic form. Can somebody tell me what we would have? I know. Camden already told me. All right. We've got 9x squared. Wait. Is it minus? You would minus the 4 over, and you would get plus 5y squared. Okay. After this, what do we have? Plus 16y minus 16 equals 0. So, what is this? It's an ellipse, okay. How do we know it's an ellipse?
Because the coefficient, they're not the coefficient.
Yeah, you're right. The coefficients are different. Yeah. Okay. All right. Can somebody now? We're gonna have to think about this for a second. We have done a parabola and we've done an ellipse. What I want you guys to do is look back at the original equation and see if you can relate it to the math and maybe tell me what would be required to make a hyperbola. Okay, so we're going to I'm probably going to pause the video actually, maybe spend 5 or 10 minutes talking about it. So see if in your groups you guys can come up with an equation that would be a hyperbola. Okay, that's the goal. Okay, does somebody want to explain how we could get a hyperbola? Yeah, okay, so give me, maybe tell me what equation you chose. Did you come up with an equation? Did anyone come up with an equation that would give a hyperbola? We all just talked about what it would be. Okay. So what did you guys notice?
I thought it would be in the first one it's parabola, and the number under 1 is 3 minus 3 or theta. So I thought if it was a different number, the numbers in the front, the coefficients are different.
Okay. So on this one they're different. The 3 and the 2, those two are different there. But it's a plus. So you thought if they were different but it was a minus, it would be a hyperbola? Okay. Anyone else have other thoughts? So if this one was a plus, would it be an ellipse?
What?
If this one was a plus, would it be an ellipse? So wait, let's think this through though. If this was a plus, where in the work would it change it? It'd be this right here, right? Yeah. Okay. So if it had been a plus, that would have been positive 3x, and we would have subtracted it over. So the minus and the plus, if you can see it, this one up here was a plus 2y, so we're a plus 2y and negative 2y right here. What did the 3x become in the final equation? As we did our math, it was right here, there's the 3x, it became the 9x squared. What did the negative 2y become? The 4y squared. Does the sign matter for that part? The sign doesn't matter for that part. Okay, so it's different than the sign. It's not the plus, it's not the minus, it has something else. Did anyone else notice anything? It's a good thought, though. It's a good thought. It wasn't a bad thought, it just doesn't affect it. Yeah.
The coefficients before r and r cosine theta or sine theta.
Uh-huh.
If they're the same, then it's a parabola.
Okay, can you tell me why, if they're the same, it makes it a parabola?
Because then it'll cancel out one of the square terms.
Yeah. Do you guys see that? How the 3 squared on the bottom, we divided by 3 in the front, right? Does everyone see that? We divided by 3 in the front. And then when we squared it, that brought the 9 back over here. So if the 9 squared over here and the 9 squared and the 3 squared over here make the 9, what ends up happening? When you minus it over, it cancels out, right? Okay. So then, Caleb, you want to explain the part with this one?
Okay. So if the coefficient for r is greater than the second coefficient in an ellipse,
Okay.
because when you divide that coefficient over, then you need to re-multiply it because it's on the bottom, and that causes the square terms, I guess, to be greater than whatever you're going to subtract over again.
Okay, so if you guys look at this, does everyone see the 3 and the 2? Are you paying attention to that? So the 3, the number in the front always ends up being underneath the fraction, so that 3 ends up being squared, right? And then that 9 ends up in the front and it ends up distributed. And then what he just said is this 2, the number in front of the sign, that's what became the 2y and that's what got subtracted over. And when we square that number, we get 4y squared. So for this to become a hyperbola, what do we want with the 9 and the 4? If we do 9 minus 4, what's going to happen?
You'll get a positive number.
Positive 5. So that's always going to make an ellipse. If this number is bigger than this one, when we subtract it over, it's always going to be an ellipse. So what do we want to switch about these two numbers to make a hyperbola? This one has to be smaller than this one. So what could we have switched around about this exact problem to turn it into a hyperbola instead? Switch the 2 and the 3. Okay, so let's try that. So we're going to do r equals 4, and we're going to switch the 2 and the 3. Okay, what do we do first? Yeah, so multiply. So we have 2r plus 3r sine theta equals 4. And then what do we do? Yeah, so substitutions, replacing the r with the square root of x squared plus y squared, and replacing r sine theta with y. And then what do we do? So 2 x squared plus y squared. Are you guys bored of these problems yet? I know, they are the same. Yeah, for people who like the number crunchiness of it, it's kind of nice. And it is nice to not have any more, like people... number crunching, where it's just like, you know what I mean?
Yeah,
like doing lots of numbers the whole time. Alright, divide by 2. They're nice because it's not like you have to think through it every time. These ones you can kind of zone out while you're working on them, because they all really do work out the same. So, at the point where I've got that radical all alone, what am I doing? Squaring both sides. And I'll go ahead and write this twice, so it's easier for me to FOIL it. So at this point, what should I do? And then can we see how it's about to make a hyperbola? Can you guys tell which way this hyperbola would open? Would it be left and right or up and down? It'd be left and right. How do you know it's left and right? The y's are going to be the ones that are negative, so they would go second, yeah. Okay, so general conic form, we've got 4x squared minus 5y squared minus 24y minus plus 24y minus 16 equals 0. So there's our general conic form. We've got a hyperbola.